session is being recorded. You can enable captions by clicking on the Show Captions button at the bottom of the screen. Douglas will be sharing, will share his email address with you if you want to contact him later with questions. And now let me welcome Douglas Dechow, Assistant Dean for Research and Data Services at the Leatherby Libraries of Chapman University. Douglas is the co-author or co-editor of a number of books, including Your Craft as a Teaching Librarian, Using Acting Skills to Create a Dynamic Presence. Please join me in welcoming Douglas.
Hello, everyone. I'm going to go ahead and share my screen. Chris, thank you so much for that introduction, and thank all of you attendees for being here today. We really appreciate it when you pull together a workshop and folks bother to show up. We're going to jump right into my talk today, Colloquial Data Science in Libraries. And we're going to start, of course, at the beginning. What is data science? There's a very nice definition on this webpage, which comes to us from the NNLM, the National Network of the Library of Medicine. If you're not familiar with the NNLM, I'm hoping most of you are, but if you're not, they actually run some very great workshops and tutorials on generative AI, data science, things like that. So they know what they're talking about. They deal with a lot of data, and they do a good job at sharing that information with others. As you can see, it says here, data science is an interdisciplinary field which uses statistics, computer science, programming, domain knowledge, etc., for gathering data and asking questions of that data to solve a problem. It also includes sharing that the information that you acquire through storytelling and data visualization. And the technologies that underlie it are often methods such as machine learning, AI, natural language processing, algorithms, and other kinds of ways of getting to grips with that data. They provide a couple of really good examples here. An example of the use of data science would be creating a machine learning model that uses data from large amounts of electronic health records, EHRs, to predict if a patient is at higher risk for readmission after a hospital discharge, and so on. And then they give a couple of nice examples of tools. It says data science uses a variety of open source and proprietary software, e.g. Python and R. I would actually sort of move that parenthetical to after open source. Those are both open source tools, not proprietary tools, and we can talk about that if you have questions. And tools include software and programming languages to build and run data science models, tools to extract, organize, clean data, and tools to visualize and share findings. Adding to that list of tools is the reason that we're here today. I'd like to propose that large language models, such as the GPT family, Gemini, Claude, etc., are able to assist us in doing data science, colloquial data science. We go on to the next slide. Well, what is colloquial data science? Well, underpinning all of those various activities in data science. So data science, again, is about asking questions of our data and programming and using programming languages and statistical models. It's underpinned by a range of pragmatic tasks. Data cleaning, so tasks such as identifying and filling in missing values, removing duplicates, data type conversion, exploratory data analysis, so getting a sense of what's in our data and what kinds of questions it can support answering. Data visualization is an important part of every aspect of data science, really. It plays an important role in exploratory data analysis so that we can have an idea of what's in there. And then it also helps us tell the stories that we've uncovered. And of course, statistical analysis and machine learning, those are the models that we use to ask those questions. Well, colloquial data science is performing those activities by prompting a large language model using ordinary natural language. English in my case, but of course, most large language models understand multiple languages. And of course, English will be the case for this workshop. And it's a way of using that natural language, not a programming language, though we'll talk about how programming languages are still involved to solve data-oriented problems. By the way, I didn't come up with this terminology. I wish I had, colloquial data science. I first heard it in a workshop taught by Dr. Peter Gruber last fall. He's one of those academic unicorns with 2 PhDs, one in particle physics and a second in the area of economics, computational finance. He's a pretty smart guy, and he's thought about this. And did my screen go blank? Did the slides disappear for folks?
They did, yes.
I don't know why that happened. There we go. They seem to be back now. Sorry about that, folks. All right. So one of the things that we want to talk about is, I just want to say a few words about how large language models learn these skills for data science, particularly how did large language models learn to program? Because most of data science involves translating mathematical models and data-oriented processes into a programming language. So when we're talking about colloquial data science, we still want to have an understanding of some of these things, but it's really removing that, the barrier to entry that we're removing is having to be a very good programmer. It's of course going to help if you understand a little bit about programming languages, and I'll say more about that as we go along. But really, colloquial data science sort of removes the need for us to be a highly skilled programmer, and we can still make sense of our data. So, for example, this slide describes the training data sets that have been used for a number of popular large language models. Particularly in the upper right-hand corner, you'll see one called Llama. This is from Meta, large language model, Meta AI. And if you see in the list of things that it was trained on, you'll see highlighted in blue, GitHub, Archive, and Stack Exchange. Well, these are all enormous repositories of programming language information, and particularly in the case of Archive, statistical and machine learning information. So these are just vast treasure troves of work that others have created and submitted, and then they were used as training data in that particular large language model. The one beneath that from Google, Palm, which is the Pathways language model, well, that's the predecessor to their current language model, Gemini. And as you can see, it explicitly mentions that source code was used to train it, and the code includes 24 different programming languages. So that presumably Gemini is able to generate code in 24 different programming languages. Now, that has some implications for some of the things that we're going to be doing, but while what a large language model is trained upon is crucial, for our topic today, the design of the chatbot that you use to interact with the programming with the large language model, the chatbot that connects the user to the large language model is every bit as important. So all of the current large language models that are in common use can be helpful for data science, but several of them have limitations. So the one that we're going to be focusing on today, and I'll say a bit more about that, why we're doing that, is GPT-4 and GPT-4 Omni, the one that was just recently released. For those large language models, Python is the preferred language, though again, there are dozens of other programming languages and statistical languages, Stata, MATLAB, R, etc., that they will generate code in. But the key differentiator between the 4 model, GPT-4 models, is that they'll execute the code for you in real time in ChatGPT. And I'll show you some examples of that. They will also produce visualizations. GPT 3.5 will not do that. Gemini, as when I most recently checked in on it in early May of this year, it would not execute code, though it generated excellent code, but it would not execute it for you in real time. And the same thing with Claude. Now, there are some strategies for if that's one of your preferred large language models, or if, as we'll see, GPT 4.0 for Omni is free in a limited sense and will sometimes default if you're not a paid user to 3.5. But there are strategies for being able to deal with that situation where the large language models generates the code for you, but you have to find somewhere else to execute it. So ultimately, most of today's workshop is going to focus on ChatGPT and the version using OpenAI's most recent release for Omni. About a month ago, when for Omni was released, OpenAI introduced a free tier for this new model. So 2 months ago, when I submitted the proposal for the workshop, the landscape looked quite a bit different. Over the past year, when I've introduced colloquial data science to groups on my campus, particularly STEM graduate students, I've spent quite a bit of time on how to use ChatGPT 3.5 effectively for those tasks. That information is still in this slide deck and will be available, but when we get to that point in the talk today, we're going to go through it very quickly so we can see some of the other features of these tools. And so just some things to keep in mind. The free tier of GPT for Omni is exactly the same as the paid for tier. It's just limited in the number of questions that you can ask it, and it's limited in how many times you can access it in a day. I've seen a variety of limitations. Sometimes it's also dependent upon what's going on inside the machine at that particular time. But it's still a fascinating thing that they chose to finally make, their latest and greatest model available to all of us. All right,
Douglas, we have received one question in the Q&A box.
Sure.
Can you remind us of the name of the professor who came up with the term colloquial data science?
Yeah, his name is Dr. Peter Gruber. He is at a university in Italy. I have forgotten exactly the name of that, but if that's somebody that you would like to contact, just shoot me an email and I can provide you his contact information. He teaches online workshops through a resource called InStats. I don't know if you're familiar with that, but InStats has a broad range of paid for workshops in these areas, and it's a great resource if you can find the funding to take them. All right, so for today's, for the work that we're going to do, and we're going to try and do some of this in real time. I do have previous chats from ChatGPT where I solve these problems available. And if ChatGPT is being a little challenging to work with today, we can jump into those and you can still see what I've done. But for today's exercise, we're going to use a data set from Kaggle. Kaggle's a website with publicly available data sets. It actually does quite a bit more than that. But really just getting data is enough for our concerns today. And we're going to use two files from the Seattle Library Checkout Records data set. The first of these files is a file called library collection inventory.csv. It's a pretty good size file. It's almost a gigabyte. It's 852 megabytes. And then we're going to use the second one called checkouts by title data lens for 2005, and it's 280 megabytes. Now, this isn't exactly what I'm going to be using for the workshop, and hopefully I'll be able to get these modified versions of these files up for folks to download lately. But these data sets are too large for ChatGPT to process consistently. I did manage to get the second full data set, the title bearing data set, the 280 megabyte ones to load for processing for a couple of times. But on many occasions, ChatGPT just gave me an error message. Now, in theory, ChatGPT should be able to handle a single 512 megabyte data set. I know that because I tried to upload the 800 megabyte one and it told me too large. The maximum file size is 512, but I've never managed to get anything close to that size to upload so I can work with it. So I had to slim each of these data sets down to about 100 megabytes, still a good chunk of data. There are millions of rows of data in each of these data sets. So they'll be very suitable for our purpose today. All right, so let's start with a bit of a live demo and see how far we can get. If anybody's discovered a great way to teach from ChatGPT, I would love to hear it because I found it to be a little bit challenging these days. In fact, right now, there we go. My Zoom bar was giving me some issues. So I'm going to drop our first data set into ChatGPT and see if it will process it for us. And that is checkouts by title. And you just drag it and drop it, and you'll see as ChatGPT tries to upload it, if it takes too long, we'll switch over to one of the other things. But once that data set's in there, we're going to use a prompt. Yeah, it failed. All right. So I've been getting this message a lot lately, and really it's time of day. Right now is the busiest hours of the day. I'm in California. That's where ChatGPT is located, and that's where OpenAI is located. And often, I'm not going to try it again. We'll just jump over to the previously stored chat where I did this. Apologies, but this does happen with ChatGPT. So here's an example of an earlier chat that I ran. Uploaded that exact same data set. And you'll see one of the things that it does is it gives us a little snapshot of the data set. And it tells us all of the various rows. So all of the variables, if you will, that are in this particular data set. And then, of course, it'll display the first few observations or instances or whatever, however you prefer, whatever preferred terminology you have for denoting the actual examples of a particular piece of data. So I've used a prompt here that says, that provides some context, and I generally find that to be beneficial. You'll see, we're not going to cover this in today's workshop, but you'll see in the slide deck that I tend to use the bits and pieces of a prompt framework called the proper prompt framework. Again, it's in the slide set, also from Dr. Peter Gruber. It's one that he says works pretty well for processing statistical information, and you'll see some of the bits and pieces in that. But I've told the chatbot, the large language model, to play a role, and that role is of a librarian who's interested in analyzing the data set that they have received from their supervisor. In terms of statistics and data analysis, the librarian is only familiar with measures of central tendency, so mean, median, and mode, not a particularly sophisticated statistical user. That kind of information helps guide the large language model in terms of the kind of results that it's going to give. They need to understand what the data set is about and what it can tell them. So what's the next step? And here's what ChatGPT is telling me. The data set contains information about library checkouts and includes the following columns: bib number, item barcode, item type, collection, call number, data. Also notice that, of course, even though, if you look at the data, there's no extraneous information in here, but in the case of each of these fields, bib number, item, barcode, the large language model is trying to tell us what it thinks, and I use thinks in air quotes, that particular variable represents. So bib number is the unique identifier for the bibliographic record. Item barcode, the barcode of the item checked out. Again, this is one of those areas that you want to pay close attention to if you're familiar with the data. We've all heard about the hallucinations that are possible in large language models. And in this kind of work, this is one of the places where that can happen, though I have generally found that it does a very good job at telling me what kind of data is stored in a particular variable and what that variable represents. And then it goes on to say, given your familiarity with measures of central tendency, we can start by calculating some basic statistics for this data set. Here are a few of the initial steps that we could take. You'll notice, and I'm sure you've seen this before, but at the end of each of these responses from the large language model, there's a little chevron surrounded by some brackets, and that's going to be where the code is that it's proposing to run or has run. So I've asked it to go ahead and please proceed with the initial suggested steps. Here's what it responds. And you'll notice in its response, it's telling me that even though I'm giving it a slimmed down data set, one of the areas in that data set, the checkout dates, it needed to convert to a datetime format, was taking too long. So it also sampled the data set, which was already a sample. So, you know, we're losing some accuracy in terms of the information that we're processing here. But again, there are a couple of ways of dealing with that. Let's continue on. Here's a summary of the analysis that it did above. Mean checkout date, median checkout date, that sort of thing. And again, it actually provides all of the code. Now, I said in a previous slide that the preferred tool or the preferred programming language, the one that it's most comfortable providing answers in is Python. And that's what we have here. This is a sample of Python code that it used to generate those answers. So it's actually generating code that we could use elsewhere, and we'll talk about some ways of doing that, and then running that code for us and providing the responses for us. As far as I know, of the popular current large language models, the four models, GPT-4 and GPT-4 Omni, are the only ones that can do that. Now, it's trending in the direction of doing what's known as an exploratory data analysis. So the next prompt that I give it is, I've heard that an exploratory data analysis can be useful for understanding a data set. Please explain it to me, and can we do it on this data set? And then it gives me a pretty solid answer of what an exploratory data analysis is and how we might go about doing that. I'm not going to go through all of these bits, but one of the things that I want to point out is, again, all I just asked it was, can we do one? I didn't even ask it to do it, and it went ahead and did it, including generating some initial visualizations of those various data types. Now it's still live. So you'll notice this is a relatively recent feature. They've made these visualizations interactive, and it gives me the exact numbers of each of these bars. So how many items were, what's the frequency of the checked out item type? 36,269 for this ACBK field. This chart is downloadable, so I could go ahead and grab it and put it in a presentation if I wanted to, and I did just that. And in addition to these other kinds of simple visualizations, it also provides some descriptive statistics for me. So it gives me the basic calculations that you would want to perform. Now, those numbers don't make sense in all of these. Performing statistics on unique identifiers and finding the mean of those unique identifiers, not particularly helpful, but it doesn't know that. So this is where we have to be thoughtful, where we have to know what questions we want to ask of the data.
Douglas, there's a question
Sure.
that's been asked that kind of relates to that.
Sure.
Mara asks, have you experimented with uploading a codebook or data dictionary along with a data set to provide additional context?
No, I haven't done that. I've done something similar, which is kind of the next thing that I'm going to talk about in just a second, but that's actually the next thing that I want to do. So, whenever you give a talk like this, there might be an assumption that you're an expert in doing it. I'm still learning as we go along. I just find this a fascinating thing that we can do with these tools and provide to our patrons and our users as some guidance. So, but thank you for that question, and thank you for that idea, because that's one of the next things that I want to try. But I have uploaded two data sets or two data files from the same data set and been able to ask questions of two data sets that I wasn't able to ask of one of the individual data files. And I'll show you that in just a second. Now, I'm going to jump back to my talk for just a little bit, and we'll skip ahead of all those things that we just discussed. I want to say a little bit about various Python programming environments. So one of the things that you can one of the benefits of using large language models to do this kind of data analysis, data science, is that you don't have to be a programmer. But so you may want to run these analyses or run that code that it gives you more than one time. And so having some knowledge of Python or R or some other programming language that these tools will generate code for is probably not a bad idea. So I don't think we're quite to the point yet, if for no other reason that there are significant file size limitations in these devices. So it's still a good idea to know a little bit about how to do some coding. And, I think we're at the point where most libraries have somebody in-house who has some level of familiarity with coding. If you don't happen to be that person, and you still need to do this kind of data analysis, you should by all means reach out to them. There are a number of ways, again, almost the lingua franca of most of these LLMs is Python, and that's because Python is far and away the most popular data science programming language at this moment in time. There are a number of different programming environments that are available to you for Python. The one I recommend is Google Colab. There's only one tiny sort of caveat gotcha with Google Colab, and that's if you're going to upload the files that you want to work on to your G drive, you have to jump through some hoops. It's not as simple as you might think to just begin immediately working with the data. So if we go back to the chat generated by ChatGPT, yeah, so we'll see right at the top. So if you're not familiar with programming, one of the things that you have to do is load the data into the programming environment so it can begin the processing. And that's what we see right here in this code that OpenAI's large language model has generated for us. It says file path, and then here's the name of the file that I actually copied and pasted or tried to copy and paste into the system. And it reads it and loads it and puts it in a variable so you can begin doing manipulation. This won't work on Colab, right? So this idea, this metaphor, this process is what you have to follow, but this exact language will not get you to your data. And that's just one of really the only tricky thing about using Colab. You have to go through this process of mounting the hard drive, mounting your particular file area in Google Drive. And then when you load the file into the programming environment, you have to go through this fairly lengthy process of giving it a path to your data, where it lives in your G drive, in order for it to be able to in order for it to be able to load that file. So you need to give the location of the data set. That's not horribly complicated, but it can be a little tricky. And from time to time, people don't get it right and gives it errors. But again, that's one of the interesting things about this is an error that happens a lot. So there's a lot of information out there on the internet about how to ameliorate that error. And often as not, if you put that error back into ChatGPT and say, hey, I got this error, it will assist you in figuring out what's the correct thing to do. Once you've done that, and this sort of speaks to if you're run out of queries for ChatGPT 4 and 4.0 for that day, or you're using one of the other large language, you're fond of Gemini or Claude for whatever reason, and you need to do this kind of work. One of the things that you can find yourself doing, having to be in the position of, is uploading the data by hand. Obviously, with an 800 megabyte file, you're not going to do that. The way to get around that is to just, again, download or copy and paste a snippet, a healthy chunk of that data, put it into ChatGPT, let it tell you what to do with it, and then generate the code for doing that. And then you can move it to Colab and proceed with the analysis yourself if you need to do that. So I want to jump back. I want to move on to a bit more of an advanced data analysis activity. But are there any questions at this moment in time? So I had mentioned a little bit ago that when the question about uploading a data dictionary or a code book had come up, one of the things that I've been playing around recently was asking questions that can't be answered by a single data set, but require information from two different data files in that data set. And so in that particular, in that vein, with these particular data sets, one question like that you might ask is, what are the titles of the 10 most commonly checked out titles of the 10 most commonly checked out items? So in this checkouts by title from Data Lens, oddly enough, let's see. So this is that file. So there's an interesting bit of file naming going on here. But so in checkout by title Data Lens from 2005, this is their checkout data, and this is the 100 megabyte version of the file, not the full 275 megabyte version. If you look at the various fields that are available to us, the actual title isn't one of them, right? So we can't ask this particular data to tell us what the title of is in the most commonly checked out items. All we have to uniquely identify these items are the bib number and the item barcode. We don't have the title. Whereas in the second data set, which is library collection inventory, this, and I'm sorry it's not able to display the fields and some of the information from those fields right now. But if we had that, we would see that this is every individual item in the collection, but it doesn't have any checkout data. So it's the full metadata for an individual item, but nothing about when it was checked out. So in order to answer this question, what are the titles of the 10 most commonly checked out items, we actually need to bring both of these data sets together in some way. Now, that's a pretty easy thing to do in some programming languages. In the database language, structured query language, SQL, we can do it pretty in a straightforward manner in Python. But if you don't know how to do that, then, where would you even start? Well, you can start with here. So again, here's our prompt. Please play the role of a librarian who's interested in analyzing a data set that they've received from their supervisor. Use the call number field in the uploaded data set to determine the 10 most commonly checked out items. Please display those results as a bar chart. So we want to make sure that at least we can get that, that the information that we think is in this CSV data file, comma separated variable data file, is in there. Can I find out what the 10 most commonly checked out items are? Sure enough, we can do that. Here's the bar chart displaying the 10 most commonly checked out items based on the call number field. If you need any further analysis or a different type of visualization, feel free to let me know. And again, there's the code that it used to do that, to create that little chart. So please produce a bulleted list of the bib number. That's the unique identifier in that particular data set for those commonly checked out items. Well, goes ahead and does that. So here's that data. All right. So now what I want to do is take this unique bib number and use it as sort of a key, if you will, to get into this second data set, library collection inventory, which does contain titles. Now, so when I was initially playing around with this data, I kept getting an error and it didn't make sense to me. And this is one of those areas where you have to pay close attention and think through things. It turns out that in this second data set, library collection inventory, and again, this is the 100 megabyte version of it, not the 800 megabyte version of it, The field that contains the unique bibliographic number is actually not named bib number, but named bib num. All right. So there's a slight inconsistency between the naming of the data in these two files. So this second data set contains information about the items in the collection. The two data sets have a field in common. The checkout by title data lens 2005, 100 megabyte, it's a long file name, data set. The field is called bib number. In the library collection inventory 100 megabyte data set, the field is known as bib num. Please merge the two data sets on this field. The library collection inventory 100 megabyte data set has a title field. Use the merge data set to identify the 10 most commonly checked out items and print the titles of those items. And here, of course, is the response to that question. So here's what the 10 most checked out items were. Now, this is where, again, I just want to remind you of something. These may not actually be the correct titles. And this is nothing to do with what the large language, this is not a hallucination or anything like this. This is simply an artifact of the way that I had to work with this data, right? So I had to take the full 850 plus megabyte file and slim it down to 100 megabytes. So I left out a lot of data, a lot of titles. So it's quite possible that the actual, although Harry Potter and the Order of Phoenix does seem likely to have been the most checked out item in 2005, but it's possible that there was an item that was checked out more and was removed from that data set, all right? It still went ahead and did its best job and tried to answer the question. So if you were doing this for a real report, what you would want to do is to then take the code that it's generated for you, showing you how to do this, and use the real data set and the real data file in something like Google Colab or Anaconda or something like that. And here's the code to do that. And you can see generates, just like we saw, 10 most commonly checked out items, etc. So another reason for doing, another reason for developing some comfort with working in Google Colab or something like that, or one of the other programming environments is, remember, this data set is 2005. Well, what if I want to run it on 2006? So I could go back to OpenAI and just replace that data set, or I could just do this from a programmatic environment like Google Colab and switch it in the 2006 data file for the 2005 data file. Code should work just fine, and I'll get the answer for that year. All right. Yeah, so we just went that. So with that, we have about 6 minutes left. And I'll happily take any, so that's my presentation for today. I'll happily take any questions that you might have about this or any other ideas that you might have or questions that you might have about doing this kind of work. Thank you again for your attendance today. Greatly appreciated.
All right, Douglas, we have a couple of questions in the Q&A.
Sure.
One is, do you pay for access to ChatGPT-4 or does your library pay for it? I see so much value in getting ChatGPT-4, but I also don't want to pay out of my own personal pocket. And that's from an anonymous attendee.
I don't blame you for being anonymous about that. This is a question that's going on at, unless you're Arizona State or Michigan, who both just licensed ChatGPT, you're kind of on your own. Mine was paid for a while, but the university has decided it's not going to. So now I pay out of my own pocket. And again, it's because of the value of doing this kind of work.
All right, and then there's a couple of questions that have to do with this example. First from Amanda, what would have happened if the title associated with that bib number wasn't in the data set you uploaded for the second file? How would you know that it executed it right and got correct results?
Yeah, so this is this is one of those things where, you know, you need to go a little bit deeper. So that's a great question. Thank you for that. Where you need to go a little bit deeper. If you go into the code, you would notice that if something is missing, it moves on to the next most highest rated one. You'll also know that there's no title or no comparison for these first two of the 10 most checked out items, ILL and Unicat. So it's not until the third one that we start actually getting items. So it's just getting rid of those and moving on to the next one. But that can be a little tricky. And again, that's going to be much trickier with this situation because we're using sampled data sets on both sides. So it's entirely possible that that's definitely going to happen. There are going to be bib numbers in our collection data that are not available in the checkout data because we got rid of them in both sides. So that's definitely something that you want to work out.
And then also from Kevin, when you asked specifically for titles, why did it also include author information?
Yeah, so if you go into the code, I'm going to have to say, so I was expecting it to do so sometime, and again, this is something that you want to pay attention, just like at the very beginning of the talk, when it started, when the very first question, I think it was in here. Yeah, where I said, what is the next step? It went off and did some analysis on its own. Sometimes because of the way that it's been trained, it's just going to assume that you also want that secondary piece of information and join them together. But I'm actually going to say I'm a little confused because it doesn't seem to be doing that in the code itself. So I'm going to have to say I don't know because it shouldn't have done that.
Another new question from Taylor. If you can do this multiple times with the exact same data sets and prompts, would the code come out exactly the same, or would you expect some variation?
You know, so thank you to Taylor for that question, because that's actually something I meant to address in the talk and just sort of rode right past it. Again, it's generative AI. It will generate different code solutions. Not, you know, in my experience, not every time, but sometimes it generates wildly different solutions. So it's not a bad idea if you're asking these questions multiple times to save multiple versions of the code and see how it differs from run to run, because it will not give it's not going to give you exactly the same piece of Python code every single time. It's just like the other kinds of writing that it does. It differs from run to run. Same thing with the code. You don't always get the same answers. So, and sometimes it generates, just like we've seen in some, and still occasionally see in the writing, when we're asking it to do other kinds of writing, it feels kind of off because it's formal or some other part of the writing. You'll get the same thing with code. Sometimes it makes decisions to write code that you're like, wow, that's not something that I would have done. So it's a good idea to pay attention to it from run to run.
All right. I'm seeing no more new questions. A number of thanks to you in the chat for a great session, and we are at time. So let's all show appreciation one more time for Douglas Dechow and This is the next to last time block in the Gale conference. So I hope you enjoy your final session and have had a great conference experience.